Hello, everyone, and welcome to today's live broadcast, Voyage into the Captivating Realm of Cannabis Science and its Regulation, presented by Jason Lupoi, PhD, a consulting scientist and analytical chemist at the R.J. Lee Group. I'm Judy O'Rourke of LabRoots, and I'll be your moderator for today's event. We're delighted to bring you this educational web seminar presented by LabRoots. LabRoots is the leading scientific social networking website and producer of educational virtual events and webinars. Before we begin, I'd like to remind everyone this event is interactive and we encourage you to participate by submitting as many questions as you want at any time you want during the presentation. Just click on the Ask a Question box located in the far left of your screen, type your question into the drop-down box that appears on the screen. We'll answer as many questions as we have time for at the end of the presentation. If you have trouble seeing or hearing the presentation, please click on the Help Desk button located in the promotional board at the bottom center of your screen, or use the Ask a Question box to let us know that you're having a problem. This presentation is educational and thus offers continuing education credits. Please click on the Continuing Education Credits tab located in the top right corner of the presentation window and follow the process to obtain your credits. Please join me in welcoming Dr. Lupoi. I will now turn the presentation over to him.
Good afternoon, everybody. Thank you for coming to tuning in and listening to my presentation this afternoon. You know, I think it was in the early 1970s that a book was written about cannabis legalization and cannabis science. And a good friend of the author was the esteemed astronomer Carl Sagan. And when Carl Sagan found out that the author had predicted that cannabis would be legalized within 10 years, he said, "Why so pessimistic?" He thought cannabis would be legalized much sooner than 10 years. But fast forward nearly 50 years later, and here we are now finally talking about cannabis legalization, and more importantly, at least to guys like myself, cannabis science and its regulation. Today, I'm hailing to you from Pennsylvania, and I think that, you know, in my own lifetime, I never would have suspected that cannabis would be legalized and that I would be here in Pennsylvania talking to you about cannabis. And I think that's in no small way due to the efforts of guys like Ruster Sosimo and Tom Perko of the Pennsylvania Medical Cannabis Society, and really all of the Pennsylvania Medical Cannabis Society, helping to lay the foundation for us to be speaking at events like these. While I'm thanking folks, I also wanted to thank my colleagues at R.J. Lee Group. We are the auditing body for the state of Washington, so we audit all of the cannabis labs. And so therefore, I wanted to also acknowledge the Washington State Liquor and Cannabis Board for granting us the opportunity to help labs enhance their science and make sure that they're putting out defendable data. I also wanted to thank Terpenes and Testing magazine, a publication of which I recently became editor-in-chief. And this gives me a great opportunity to work with the stellar team at Terpenes and Testing magazine to help disseminate sound analytical science and cutting-edge technology. And of course, I'd like to thank LabRoots for giving me the opportunity to speak to you all today. I've broken my presentation up into 4 main themes or sections, but I'd like you all to be thinking about 2 other overarching themes while we have this discussion today. I'd like you to be thinking about, number 1, we're putting one number on packaging for cannabis products. So when a patient goes into a dispensary and they're looking at the potency of a product, they'll often see one number listed there. But there's a lot of different things that kind of go into that one number that a lab might produce. And so I wanted to walk you through some of those scientific variations and other sources of variation that can ultimately lead to that one number. I also wanted you all to be thinking about targeted therapy. So users being able to know what kind of products they should be selecting when they walk into a dispensary and when they're specifically trying to target individual ailments that they might have. Before I begin with some of the scientific aspects of the presentation, I first wanted to introduce a little bit more about who R.J. Lee Group is beyond our cannabis lab audits. Our headquarters is shown in the lower image there. That's outside of Pittsburgh, Pennsylvania, in Monroeville, Pennsylvania. We also have in the upper image the lab front of the Washington State location in Pasco, Washington. We recently put a lab up at Penn State University University and State College, and we've also got lab space down at Oak Ridge National Lab. RJ Lee Group has been part of a lot of really high-profile projects through the years, and I wanted to share with you some of those projects that kind of make us who we are here today. One of the things that we do routinely is medical device services. So often when somebody is pitching a medical device to the medical community for use, they have to first put that device through a series of tests, such as corrosion tests, wear tests, and the FDA requires all of this. And these are routine services that we provide to make sure that at the end, patients are safe whenever they're having medical devices implanted in their bodies. We've also analyzed the water in our public school systems to make sure that our children are drinking healthy, uncontaminated water. We've also, we were one of the first labs to generate methodology for the toy recall of a few years back. We were evaluating toys to make sure that they did not contain toxic substances or elements that children may be poisoned with when they're putting toys like this in their mouths, or just when they're handling them in general. We were called in to help identify the cause of an explosion of an oil derrick, and obviously to help the company make sure that this didn't happen in the future. Similarly, we were called in after a train derailment that cascaded a toxic substance into the environment. We were called in to help analyze the environmental impact and the safety of the community surrounding that. I don't think anybody will ever forget where they were on September 11th. I know that I won't. RJ Lee Group was the first lab to characterize specifically what World Trade Center dust was, that was pervasive throughout Manhattan and the surrounding areas. This was pervasive. People were breathing it, and it was also inside of businesses and required cleaning up. More recently, in a project that I've been directly associated with, we've started to analyze particulate captured through a device that we helped invent on our International Space Station to analyze the particles that our astronauts and our scientists are breathing. And so now our reach has extended from the oceans to the heavens with this project. Because we are an analytical laboratory, we have a lot of accreditations. And I think this is important because at the outset, I said that we are auditors for the state of Washington, and yet we are consistently getting audited ourselves for these various accreditations that we have. And so not only do we know what to do when we are auditors, but we also know what to do when we are being audited. And I think that becomes important when we're trying to share with labs proper methodologies and proper compliance. Most recently, we received a DEA Schedule II license to be able to analyze Schedule II drugs. Now, we're very similar to some ISO accreditation programs in a few facets. We are analyzing a checklist with the labs. The states have defined code that a lab must be compliant to, and so we evaluate whether labs in Washington are indeed compliant with what the state of Washington requires. We do go in and audit these labs. Sometimes these labs can be scheduled, sometimes they can be spontaneous. And we also evaluate proficiency test results, as do ISO accreditation programs. But we also provide some services that are additional to those three that you see listed in green at the top. And two that I wanted to point out specifically are that we helped draft the regulations in Washington State. Often regulators are not scientists, and so they may not know specifically what might be practical for a laboratory to be doing on a routine basis. And so we tried to help introduce some practical verbiage into these regulations to help labs comply more easily. We also supply analytical and regulatory consultation to both the labs and the state of Washington. And I wanted to express a little bit more about that. The regulators typically are not scientists, and they might not understand everything that's going on in the cannabis lab from a scientific or an instrumental perspective. And so we can help them understand what labs are saying when they might have some comments on the code. We've also helped guide laboratories to better comply with the state's requirements. Often laboratories are confused by some of the regulations and not quite sure what they need to be doing to be compliant. And we've helped serve as a liaison between those labs and the regulators. At the bottom, I found this Chemist's Creed, and I think this is quite profound for what not only my own objectives are with my involvements in the cannabis industry, but also what RJ Lee Group's goals are as a whole. And I'm not going to read this all to you. You can see it there for yourselves. But essentially, it discusses propagating a true understanding of chemical science and avoiding false or exaggerated statements, discouraging practices that are harmful to public interest or welfare. If that doesn't summarize what our objectives are, I don't know quite what does. So I wanted to talk a little bit about some cannabis science, but I first wanted to talk about some cannabis history. And the rationale for this is I think that a lot of people might assume that this is a new topic because it's more prevalent in the media. But in fact, cannabis is nothing new. Its earliest known usage was about 10,000 years ago as a fiber in what is now modern day Taiwan. It's been medicinally used since about 2737 BCE. Those uses were first developed in China. But it wasn't until William O'Shaughnessy introduced therapeutic uses to the West at around 1842 that Western society began to take notice. O'Shaughnessy developed a study commissioned by the British government when he was in India, and he was studying therapeutic uses of hemp and of cannabis. In the early 1930s, major drug manufacturers such as Eli Lilly or Park Davis began preparing cannabis products. But the 1937 infamous Marijuana Tax Act basically kind of squashed a lot of the research and the product line that many companies had generated. Now, this did not make cannabis illegal, but it did put a hefty tax of $100 per ounce on cannabis to transfer cannabis, and so no one could really afford this. We all know that in the late 60s and early 70s, there was a boom in cannabis usage again, and major drug companies again began developing cannabis-derived products. And I think that that's interesting that throughout, from the 30s, throughout the 70s, and even to today, with companies like GW Pharmaceuticals, pharmaceutical companies are not doubting the efficacy of these types of products. States began decriminalizing cannabis around 1973, the first state being Oregon, but it wasn't until 1996 in California that the cannabis became medically legal. And then again in 2012, Colorado and Washington followed suit with being the first states to make cannabis recreationally legal. Now, everything with cannabis starts with trichomes. So trichomes are glands that are on the plant. You can see in the bottom left figure, it looks like the plant might have frost or dew on it. Those are indeed the trichomes. And these glands contain the cannabinoids and the terpenes, the molecules that, anybody involved in the cannabis industry are after. But they serve in nature as protection from insects and animals or fungal growth. These trichomes are highly volatile. They're fragile. Things like heat, light, physical contact, oxygen, and time can dispense these contents. And so it's very paramount that people are practicing caution when they're working with these types of materials. Inside of those trichomes are phytocannabinoids. Phytocannabinoids differentiate from endocannabinoids that our body naturally produces. And I've shown eight individual cannabinoids here, but in fact, there are said to be more than 90 cannabinoids in cannabis. And I went with the conservative reference, the Frontiers in Plant Science reference that you see at the bottom right of the screen. But different sources on the internet can provide different levels of how many cannabinoids are actually reported. But I think it's important to note here that while some of these structures look very similar, they all have different chemistries. And so this starts to lead into the sources of variation variation when you're looking at different strains or even within different flowers of the same strain. On the right-hand side of this slide, you can see a table of different boiling points of the different cannabinoids. And this becomes important for users who are vaporizing products, and maybe they have a vaporizer that has a digital readout and they can set it to a specific temperature. This can help users then target cannabinoids that they know are useful for their specific ailments. These cannabinoids all start in the plant as what's called CBGA, and through a variety of enzymes native to the plant, they are then transformed into other cannabinoids that we know, such as THCA, CBDA, for example. Now, THCA is the highest concentration cannabinoid in the plant, and so. This cannabinoid is not psychoactive, and it's through the act of heating, or the fancy term is decarboxylation, that this cannabinoid is then transformed into what's called delta-9 THC. Now, this is the main psychoactive component of cannabis, and it's important to note that when labs are analyzing these types of cannabinoids, it's extremely important for edibles manufacturers to know if there is indeed THCA in their product, because it is not psychoactive. And if they end up putting THCA into their gummy bears, for example, then what you ended up buying is a glorified batch of gummy bears that have no psychoactive properties. I find it really interesting that, often we talk about with cannabis, with any product, with any pharmaceutical product that we might have in our medicine shelves, that if it's old, does it still work? Is there still some efficacy to it? And I find it interesting that with cannabis, when the main psychoactive ingredient, delta-9 THC, degrades, it creates what's called cannabinol, or CBN. And cannabinol is indicative of the freshness of the plant material, but often it's not at very high levels. If you go into a dispensary, you're not really going to see egregious levels of CBN on a product label. But I think more importantly, this has been found to be useful as a sleeping aid. And so I think that's the interesting part, that when the main ingredient of cannabis, THC, degrades, there still is something useful to be had from it in CBN. Now, we have cannabinoid receptors in our body. There's two types of cannabinoid receptors. There's CB1 receptors, which are found mostly in the brain, and there's CB2 receptors, which are found mostly in the immune system. And while this slide kind of oversimplifies the relationship, sort of this lock and key fit between cannabinoids and cannabinoid receptors, which is not really accurate, the main take-home message behind this slide, if you look at the schematic of the body on the right, is all of those colored dots correspond to where cannabinoid receptors have been found. And so it's thought that because they're distributed all over the body, this is what allows cannabis to be so useful for so many different ailments. Now, I think one thing that's important to note is that you don't have the possibility of overdosing. It's a physiological impossibility. And this is in part due to several things. The body produces endocannabinoids itself, and cannabinoids are known to limit excessive activity. So essentially they tell other neurotransmitters to cool it when they're firing too fast. So this is a sort of a homeostasis mechanism. And it's recently been found that there's a hormone in our bodies called pregnenolone that when we ingest too much THC, the levels of this hormone go up. And so it's kind of pumping the brakes on the effects of THC. Importantly, cannabinoid receptors are not located in the brainstem, which is an area controlling respiration. And so this is one of the key contrasts to how users of opiates can overdose, because there are opioid receptors in the brainstem. But still, it's important to check dosages, because although one cannot overdose on THC, a user may not be able to handle the effects of high doses. And so it's always important to dose accurately. Now, there's been a lot of medical uses of cannabis touted. Many of them are listed on this wheel that can be found on the website Leafly. But I think the take-home message behind this slide is that it's a misconception to think that THC is not medicinal. I've often heard people say, well, THC is what gets you high, but CBD is the medicinal cannabinoid. That's just simply not true. And if you look at many of these different ailments on here, you can see that THC is indeed useful for many of these from a medicinal perspective. Now, when you walk into a dispensary, they're going to want you to smell lots of things. Now, the smells that you will be smelling have nothing to do with cannabinoids or potency, but they have everything to do with terpenes. Now, I could talk to you all about terpenes all day. But suffice to say for now, these are derived from isoprene units, so the top left molecule in the pictures above. They are the primary constituents of essential oils that are found in medicinal plants. These are used in nature to repel predators and lure pollinators, and they're responsible for the flavor and aroma of cannabis strains. Now, I've read that there's over 200 terpenes found in cannabis, and again, it's one of those numbers that when you consult different sites on the internet, you'll find a lot of different numbers as well, but I went conservative again. Now, these terpenes can help introduce something that I'm referring to as strain individuality. I've heard some growers talk about terpenes and how if they're cultivating a unique strain, unique to their specific grow house, and the guy down the street is also claiming to have that same strain, by comparing the terpene profiles, you can thereby have a fingerprint of whether those strains are indeed the same or whether there are differences and they're not the same strain. There's a lot of different terpenes, as we talked about on the last slide. I just wanted to share a few with you, some of the more common terpenes to cannabis. There's myrcene. Myrcene is the main terpene in many hops. And so if you're a fan of IPAs like myself, and you see all these little nuances between the different beers, the different scent and flavor profiles, that has a lot to do with the hops that are being used to produce the beer. Myrcene is also the most common terpene produced by cannabis. It's thought that myrcene helps cannabinoid effects occur more quickly, and this is due to helping the cannabinoid pass across the blood-brain barrier more readily. Additionally, it's thought that myrcene helps increase the maximum saturation level of the CB1 receptor. And so strains higher in myrcene are thought to give a greater psychoactive effect. So those last two bullet points there kind of show you this synergy that can be had between having the terpene present with the cannabinoid. And myrcene has also been shown in the literature to be an inhibitor of gastric and duodenal ulcers. Another common terpene to cannabis is caryophyllene. Now, this is the terpene that gives things like black pepper their characteristic spicy aromas. And it's the only known terpene to interact with the endocannabinoid system. So again, there's this synergy between the cannabinoid and the terpene. Caryophyllene has been studied in cancer treatments, chronic pain treatments, arthritis, and things like neuropathy, to name a few. We're all familiar with limonene if we've ever used an orange-based or citrus-based cleaner that was derived from natural products. Limonene is formed from pinene in nature, and it's thought that limonene promotes a positive or uplifting mood or attitude. Importantly, at least for topical applications, limonene's been shown to help other terpenes readily absorb through the skin and tissue. We use limonene as a cleaner due to its antifungal and antibacterial properties, and it's also known to be a natural insecticide. Pinene is the most widely encountered terpene in nature, and if you've ever walked through a forest and you felt like you could breathe a lot better, it's because pinene has been shown to be an expectorant and a bronchodilator, so it's quite important in respiration. Lastly, there's linalool, one of my personal favorites. Linalool is what gives things like lavender and bergamot it's their characteristic scents. Linalool is thought to produce a calming or a relaxing effect, and it's also thought to be a sleep aid. So one can now see if we're taking some CBN that we talked about on a previous slide, which is known to be a sleeping aid, and we're adding in some linalool, perhaps we have a more effective sleeping aid. It's also thought that linalool helps lessen THC-induced anxiety. And so if there's new users to the industry and they're worried about, THC-induced paranoia or anxiety, perhaps finding strains with linalool or higher concentrations of linalool will help lessen those effects. So we talked about on the last slide the synergy between these cannabinoids and these terpenes. And that's something that was talked about in a paper by Ethan Russo, which is cited at the bottom of the slide, and it was called the entourage effect. And so on this slide, we see a recreation of some tables that were in that paper. And so on the left, there are some different terpenes found in cannabis. The column just to the right is what types of plants these are commonly found in besides cannabis. The column that says pharmacological activity shows a variety of the different medical ailments that these terpenes have been studied in, and all of those correspond to specific medical studies that are cited in the review paper cited below. And I think the important take-home message here is that these researchers of these various medical studies evaluated whether the cannabinoids by themselves had as high of an efficacy for treating these different ailments versus having the cannabinoid in conjunction with the terpene. And it's been found repeatedly that having that terpene present helps these cannabinoids better do their job. Now, again, when a patient walks into a dispensary, they're going to be bombarded with lots of different strain names. So strain names like Obama or Michael Phelps tell you nothing about the chemistry of the sample. And so what it really boils down to is having an understanding of what the different scent profiles are, because that's what you're going to be asked to be smelling. They're going to open the jar and you're going to smell this. And if you can kind of train your nose to know that, well, strains that have a citrus smell are likely high in limonene, and limonene has been used in these various studies for treating medical ailments, then you can better select strains that might help you combat your medical ailments with a more targeted approach. Another thing that's a big conundrum in the industry is this debate of cannabis indica versus cannabis sativa. And I like this graphic because they made it a nice periodic table, and after all, I am a chemist. But you can see that there's some indicas on the left and some hybrids in the center in green, and some sativas on the right in red. Now, there's a variety of characteristics, sort of anecdotal descriptions of what these different strains can do, but this is all relative to an individual. I've heard people talk about sativas being uplifting or energizing. I knew somebody that referred to these as clean the house strains because he felt like he could clean his house much more effectively. Then you have indicas, which are thought to be couch lock strains, so you're definitely not going to be cleaning your house. Then you have strains in the middle that perhaps might give you kind of the best of both worlds. But the real picture behind indica and sativa are not really these anecdotal stories told by bud tenders, but it's more morphological differences. So indicas are used to growing in harsher environments. Think Nepal or India, the Kush region, and they're dense, they're short, they're stubby, they have broad leaves. They produce a thick THC resin to help aid in protecting them from the harsher environments that they're found in. They're known to have higher CBD content than sativas, and they have faster flowering times than sativas. Sativas, on the other hand, hail from much warmer climates, so think Mexico or Colombia or Thailand. These are tall and lean, they have less broad leaves, and they have longer flowering times. That's really the true picture behind indica and sativa. These other types of anecdotal differences are much more on an individual by individual basis. There's also consistently a debate of flowers versus concentrates. In Pennsylvania, they're not selling flower at the outset, which I find strange. But people that are in serious pain, they need something that's fast-acting, and flower has been shown to be fast-acting. Concentrates, especially if it's an edible, those are going to take much longer to basically start taking effect. But flower, the high from ingesting flower is much shorter than the highs from ingesting an edible. Flowers definitely contain terpenes. You can smell these. Concentrates may or may not contain terpenes, as terpenes are very volatile and they can essentially bake off during the extraction process. But nowadays, many manufacturers are adding terpenes back in to give users still those characteristic scent profiles from a given strain. Flowers obviously have a very complex matrix. We talked about all of the different chemical constituents of a flower, some of the main ones at least, the cannabinoids and the terpenes. So this essentially creates this picture of a very strong natural variation. There can be a strong variation going up and down a plant, from different buds on the plant to flowers across harvest. Concentrates are thought to be much more homogeneous unless it's an edible, again, where the amount of the cannabinoids might not be equivalently distributed across something like a candy bar. And I think it's very important for people to understand that what's on a product's label when it's flower is not the sample being purchased. So if you go into a dispensary or you get lab data back from your lab and it says 25% THCA, for example, what's being purchased in the dispensary likely is not 25%. And this is again due to the natural variation. When flower is submitted to a lab for analysis, and we'll talk about this a little bit later, it's not fairly representative of the entire harvest. And so users need to exercise caution when they're reading these product labels and when they're self-titrating or dosing. I think it's also important to note that, with flower, if you're burning it, if you're smoking it, there's going to be combustion byproducts. So a lot of people have started to go to concentrates, thinking that these are cleaner, and in many ways they can be, and they started to vaporize the concentrates. Flower can contain small levels of pesticides, but it's been shown that if the flower is not clean, if there's pesticides on the flower, these pesticides can indeed concentrate in the extracts that are being produced. I wanted to show this plot here. While this citation may be fairly archaic, 1982, I think it shows a pretty useful point here, in that this compares. This was from a medical study where there was people that were smoking cannabis. There was people that had an IV of the active product ingredient, delta-9 THC, and there was people that had some type of oral product. And you can see that the smoking and the IV nearly paralleled each other in the rated high, which is listed along the y-axis. And you can see that they also had very similar degradation profiles, down to about 240 minutes or 4 hours. But the oral consumption took much longer to reach its pinnacle of the rated high, but it also lasted much longer. When we do orally consume THC, not very much of it actually makes it into the bloodstream, and this is because of the metabolism of THC in the body. It's rapidly degraded in the liver. So it's thought that, again, less than 10% is actually delivered to the bloodstream. But the molecule in the center of the slide, 11-hydroxy delta-9 THC, is what is produced in the body through this metabolism, and it's thought that this has about the same potency as delta-9 THC, which could explain then why these sorts of edibles last much longer, because even though the THC is degraded, it's creating something that's still psychoactive. And then the carboxy THC is a metabolite of the 11-hydroxy delta-9 THC, and this is the main cannabinoid that things like urine tests or drug tests are looking to find. Okay, so we've talked a lot about different chemical variations, but there's a lot of other variations that people need to be aware of when they're considering purchasing these products or creating products. Horticultural variations can significantly affect the potency of a product, and this can be things through things like lighting, the different nutrients that growers are using, soil and water quality, temperature and relative humidity, how you're controlling contamination and pests. the harvest time, the curing process, all of those things matter. And as growers, consistently try to hone their craft as artisans, they're often changing these things, which can also change the potency of their harvest. There's sample matrix variations. At the top left, these are kind of cycling through in order of lowest to highest potency. But there's things like keef. When keef is compressed, it's called hash. There's these oils, there's shatter, there's resins, there's rosins, there's butters, and on the bottom right, you see what a THC or a cannabinoid in general isolate would look like, a white powder. But it goes beyond that. There's pizzas, there's ice cream, there's funny honey, there's sriracha sauce, gourmet chocolates. These all present different matrices that a lab would have to be able to analyze. There's even on the bottom right, cannabis-infused wine. And so all of these matrices present challenges that an analytical laboratory would have to overcome to be able to successfully extract out the representative amounts of the cannabinoid such that they can be putting accurate product labels on all of these different medicinal products. There's also variations that can stem from sampling protocols. So who obtains the sample for the lab? For the lab tests? Is it trained lab staff or is it a grow selecting samples? In Colorado, for example, it was the grow that was selecting the samples, or the manufacturer was selecting samples to submit to the lab for analysis. Here in Pennsylvania, the lab staff needs to go out into the grow house and acquire a representative amount of sample. So that's quite important because the laboratory needs to make sure that they're not contaminating the grow house by coming in from the outside and acquiring these samples. So they need to be making sure they're using proper personal protective equipment, things like gloves, lab coats. They also need to be ensuring that they have clean sampling tools. I was in a grow house once in Canada, and I was asked to wear a full bodysuit overalls. I was asked to wear a hairnet, a beard net, booties. Before I put the booties on, I needed to dip my shoes into a sanitizing foot bath. And I never even set foot inside the actual grow. I was just in the portion of the building that housed the grow. So what steps are people taking to prevent contamination? Those are quite important. And also, is the amount obtained by the lab truly representative? Again, in a few slides, I would argue that it is not, at least with flower. But there are methods that are available that discuss sampling, specifically the USP, USP 40, and ASTM also has a method that discusses sampling. Again, these are not specific to cannabis just yet, but they do provide at least a foundation for a laboratory to be considering whenever they're going to be going into a grow house and sampling products to analyze. There's variance in analytical methods. I've heard a lot of people say, I took the 3 aliquots of the same sample, and I sent it off to 3 different labs, and I got 3 different answers. But I would expect that as an analytical chemist, unless the laboratories are all doing the exact same protocol. Many labs are not. There are not standardized methods in this industry that all labs are adhering to. And so unless a lab is doing the same thing as the other labs that you send your samples off to, it's not a true apples to apples comparison. There can be a lot of sources of variation introduced by the analytical testing methodologies themselves. And this can include things like different instruments, if you're doing HPLC, different solvents, different grades of solvents that people could be using, how often they maintain their equipment and how they maintain their equipment, how often they calibrate their instrument. I've seen a lot of diversity in how often labs calibrate. Some labs calibrate weekly, some labs calibrate in a much longer duration, sometimes monthly. What's the sensitivity of the equipment? What's the lowest levels it can detect? Of course, there's going to be analyst error. What's the skill of the people in the laboratory? Have they been properly trained? Are they qualified? And of course, we talked about all of the different sample matrices that can introduce significant variance. So you get a situation like this. This guy's baffled. Well, that's what happens in this industry from a consumer perspective and from people receiving laboratory data. They don't understand all of these different sources of variation are going to lead to different numbers. I would not expect people to be getting the same numbers every single time, especially with a plant that's so highly variable that contains over 500 chemical constituents. We talked about the natural variation in the plant, the chemistry. We talked about growing conditions. We did not really talk about genetics, but it's been shown that different strain names, which are nothing more than a marketing tool, may actually be genetically the same as other strains. We talked about all the different types of products that are available on the market and sampling and analytical methods. All of these things result in, combine to result in those one numbers that are being put on product labels, with no real error associated with that product label. So, I think that at this point of the seminar, I want to switch gears a little bit and kind of talk about how we at RJ Lee Group have tried to help labs at least combat the latter source of error that we talked about, and that's error and variance due to the analytical lab processes themselves. We've all seen headlines like that. That's from 1928. There's headlines that are much more current. Cannabis lab testing is the industry's dirty little secret. The federal grow house down in Mississippi has moldy samples and no federal testing standards. These types of headlines only are deleterious to this industry. They serve no one any good, and I think that they're much too pervasive. We've seen things, on our lab audits is this quest for the highest potency number. And that backdrop there from High Times, they say the strongest strain on earth was 34% THC. We've seen things like the top bullet point there where, can you do me a favor? This was published in The Stranger, an article called Can We Trust Pot Labs? Can you do me a favor and not post any flower results under 20%, oils under 75, or hash under 40%? And then the client asks the lab, if you do get a sample that's below these results, I'll get you another sample for retest. Well, retesting in the state of Washington is illegal. This is not a permitted activity. Another lab that we audited during a surprise audit, we found that a keef sample said greater than 70% THCA, and a Blue Dream sample said it was greater than 38% THCA. I asked this lab, is that the strongest strain on earth then? Why is that not in High Times? The strongest strain in the backdrop was 34%. Now, I think it's interesting that you can see here that with some of the below bullet points that these numbers, could be accurate. At least from the keef perspective, it's known that it could be as high as 70%. But these numbers threw up a red flag to us, and as auditors, we needed to do our due diligence and make sure that we were investigating this so that ultimately patients could be trusting what's on product labels. This is probably my favorite case study that I will share with you. And it's important to beware of the manipulation of data. I'll say it later, but I'll say it again here. Just because something looks scientific doesn't make it so. This piece of data, there's 5 labs that were plotted and then a supposed suspect lab. Now, this does not represent all of the laboratories in the state of Washington. Why all of the laboratories weren't plotted is unknown. But they're pointing out this sort of industry average. But again, there's no error associated with these values, and measurements without error values are pretty much devoid of meaning, especially to an analytical chemist. But we've provided the error for you, and you can see that the average is roughly about 20%, and the error at one standard deviation at 1 sigma is about 5%. So we're saying 20 plus or minus 5. So that gives you a range of anywhere between 15 and 25%. The suspected lab was at 23%, well within the range of the average when you include error. But another way, this shows you all of the labs. The suspect lab is listed as the next to last, and you can see that mean line through the center goes right through that lab. And you can see that not only that, but you can see that there are other labs also that could have been targeted by this person putting out this manipulated data, and we're not. So it's quite important that people understand data can clearly be manipulated to serve the purpose of the person manipulating that data. But a lot of labs do proficiency tests, and these are designed to help auditors assess whether that lab is good. But just because a lab passes a proficiency test doesn't really transfer that that lab is indeed a good lab or a quality analytical laboratory. These proficiency tests have some limitations right now in that, one of which is that potency is not in a cannabis matrix. Often these labs are evaluating a much simpler matrix of a cannabinoid in methanol or some solvent. And so it's not giving them this complex matrix that extracting these cannabinoids from cannabis would give. Also, there's a very wide accepted range. So if you look at those tolerance limits, the lower limit, for example, for N-butane was about 64 ppm, while the upper limit was 774 ppm. So the laboratory just needed to basically be somewhere between there, and they passed. That's much, much too wide of a range to be considered sound analytical data. There are some positives of the proficiency test, though. Recently, at least, some of these tests have been sent in hemp matrices, which are able to be shipped across state lines. And so this has started to introduce some higher complexity into the lab's evaluation. But again, are they truly representative of a lab skill? I would submit that they are not. There have been labs permanently shut down that passed their PT tests. And I think that this could be in part due to, what's known as the best behavior mentality. When you know that you're being tested, you're going to try to do the best job that you can. And, perhaps behind closed doors, things start to unravel and things become more chaotic and corners start to be cut. And then you start to see some of the problems and the lacks of compliance in the laboratory that have been pervasive in the media. Edibles have consistently presented a strong challenge for labs, and I think labs are often thrown under the bus for not producing accurate data. There on the right, you see an article that was published in the Denver Post some time ago, and they were basically exclaiming that all of these manufacturers on the left were not, putting in the amount of active product ingredient, THC, into the product that they were advertising. But we can look at this plot in two different ways. We could say either A, the manufacturer wasn't doing their due diligence and was essentially ripping off the consumer, or we could say that the lab was not accurately representing what the manufacturer did indeed put in the product. And it's important to note that these cannabinoids are what's called lipophilic molecules. They love fats and oils. And so a lot of these edibles, like if you consider a brownie or a baked good, there's going to be fats, there's going to be oils. And so an inefficient extraction of these out of there, because the cannabinoids are kind of holding on to these fats and oils so well, an inefficient extraction means that you would get lower potency than what would be expected. Well, that's indeed what this plot shows. Also, the homogeneity of the sample portion extracted is important. If you imagine, for example, a Kit Kat, Kit Kats are nicely segmented. You can break one off, and it's thought that everything is homogeneous. But imagine if there's medicinal components in there as well. Not all candy bars are separated and segmented like that. What segment did the laboratory choose for their analysis? Did they choose a portion that was not homogeneous? Were these cannabinoids localized in the product? I mean, that could significantly affect the final potency results. Labs often develop methods on flour that may not transfer to more complex matrices like food. And I think it's important to note, and I would be willing to bet that a lot of people don't know, that many states have a plus or minus 15% permissible deviation between the measured value and the product label. So that's like saying, if you measured 100 milligrams, it could really be anywhere between 85 milligrams and 115 milligrams, and things like that. All of these sort of challenges confound proper dosing. How does a patient know how much of this stuff to be consuming if they don't know accurately what's in the product to begin with? So I think, with some of our laboratory audits, we've seen labs doing a great job, and we've seen some labs needing some guidance. And often the guidance revolved around some key themes like training documentation. Has the staff been adequately trained? Things like training on the federal status of cannabis. If you have a laboratory, you can indeed be arrested. And some labs that we've gone into, their staff was not aware of that, which can be rather frightening to the unsuspected laboratory personnel. Labs often show a lack of the understanding of the traceability requirements, and I can understand that in a way, because often this industry is significantly evolving daily, and so people are trying to scramble to get this industry off the ground, and sometimes there's things that just haven't been thought about because no one's ever had to do this before. Labs often lack good documentation practices, and one thing that I find to be sometimes a problem is that sometimes laboratory directors, the scientific directors, just don't have the knowledge that they require to be able to be running all of this complex, sophisticated analytical instrumentation and ensuring that their clients are getting sound analytical, defendable data. I found this rough guide to spotting bad science, and I think a lot of these apply to situations in the cannabis industry. Number one, sensationalized headlines. We've all seen those. We all kind of know who the culprits are there for these sensationalized doom and gloom type stories. But there are things that people are doing in the cannabis industry that could then lead to those sensationalized headlines, such as using too small of a sample size, unrepresentative samples. Are we accurately evaluating products? Are we measuring enough product to be able to put one number on those? Cherry-picked results. These are all types of things that I've seen in the industry and that essentially do not help labs achieve defendable data. We don't want a situation like this where somebody is standing on a cliff, and we've scoured through the Pennsylvania code, which is still in a state of evolution as well, since this industry is certainly new to Pennsylvania. But there's things like they've recently released a sampling document that says there's supposed to be 8 to 10 grams for a 5 to 10 pound batch. Now, if you take the extremes there, a 10 gram sample from a 5 pound batch, that means that only about 0.4% of that batch is being analyzed. Is that enough? But then they added verbiage in there to say, or a quantity the approved lab and grower processor determines is sufficient to perform all of the tests. Well, one can imagine that a nefarious relationship between a lab and a grower could result in the grower saying, hey, if only take 2 grams and I'll continue my business through you. Imagine if you're only evaluating 2 grams per 5 pounds, that's 1/5 less. Now we're not even evaluating 0.1% of this highly complex plant. In Pennsylvania, the pesticide list has yet to be defined, and so laboratories are basically consulting with other states to see what they've used, and they're buying standards, from places like ResTech. They're buying standards, and they're evaluating the standards that are in there, but they're not sure if those are the ones that they should be. One that kind of confuses me is that labs are required to test for 6 cannabinoids, but processors are required to label 9. Where are they getting the data for those other 3 cannabinoids? That's going to cause some confusion and be a potential snag here in Pennsylvania. But alas, it's not all horror stories. We've seen a lot of states become more active in pitching legislation to have a legalized cannabis industry. We've seen headlines such as the top one that cannabis could help curb the opioid epidemic. I lived in Colorado for 2 years, and I did not hear about an opioid epidemic. But after moving back to Western Pennsylvania, I can tell you that it's pretty much a nightly news occurrence, something having to do with opioid problems. Even the state of Utah, 76% of voters now are in favor of legalizing medical cannabis. And even the U.S. government, in that last article there in the Telegraph, is saying that cannabis has been shown to kill cancer cells. So there's a lot of interest now in doing research and proper analytical science to determine whether some of these claims are indeed true, and if they are true, how can we start to allow people that have ailments to have alleviation from their symptoms. Standard methods are now being created as we speak. RJ Lee Group has several people involved in the ASTM International development of standards. To date, the American Herbal Pharmacopoeia has been one of the only sources that we've had for standardization. And while it's a useful starting point, if you look at some of the analytical methods therein, laboratories just aren't using these. For example, I believe the liquid chromatography method in the document has a 36-minute runtime. Labs are often using columns now and protocols that are anywhere between 5 and 8 minutes because they're trying to develop higher throughput so they can evaluate more samples in a shorter period of time. You know, we all talk about the need of standardization, but why? What's the point? Well, you can start developing better, accurate product comparisons. So if you have multiple products and everybody's doing the same method, again, that creates a much more apples to apples comparison than what we currently have. Auditors can also better evaluate laboratory data, and labs can begin to do things like round robins, where a sample could be sent off to multiple labs within the specific state, at least right now, and they could all evaluate that same sample, which will allow people to kind of understand what type of sample matrices might become problematic, and it can give some profound data on what labs are seeing. At RJ Lee, we've been able to help several labs get to this point with more defendable data. On the left, I'm showing a plot of a residual solvent calibration curve. And this lab only used 3 data points, and the state of Washington requires 4. So they weren't compliant there, and their R squared was a tad low for what the state of Washington requires. We got them to do a 6-point calibration, and you can see it's quite a profound difference. Not only are they compliant from the amount of calibration standards that they needed to do, and they chose to do more than what the state required, but their R squared shows a much more linear and accurate calibration curve. Micro failure rates are pervasive in this industry. You know, in the state of Washington, we typically see around 9 to 12% of samples failing for micro. So when we see a lab with significantly low micro failure rates, we need to do our due diligence and evaluate whether or not they're doing this right, because this is a public safety matter. And so while we're not looking for labs to be failing a certain amount, it just so happens that there is an average number of failures. So on the top lab, you see that in 2015 they were only failing about 2.5% of their samples, and we found that they were doing just a simple dilution calculation error, and you could see the difference now in 2016 and 2017. They're much more they're much more within the average of what we see from other laboratories. Lab number 2, you can see this extremely egregiously low failure rate in 2015, only 0.2%. It would be great if that was because the growers were not, the growers were doing things very, very adequately, and there was just no microbial growth on these plants. But indeed, this lab was doing what's called dry labbing. They weren't even measuring they weren't even evaluating the sample. They were just accepting the money and putting a pass label on the product, and that creates an extreme public safety issue. And one of our auditors was savvy enough to find out this by requesting to see their purchase requisitions, and he found that they couldn't possibly be doing the number of tests that they indicated because they weren't even buying enough product to do so. So RJ Lee Group is essentially interested in helping expand cannabis science. I mentioned we helped draft Washington State's regulations. We've performed over 65 audits in Washington over the last 4 to 5 years. And we know auditors because we are auditors. So we can help a laboratory get to where they need to be because, again, we've been audited ourselves, and we've been doing this for some time. We also serve on the Emerald Conference panel and advisory board. I mentioned my association with Terpenes and Testing magazine. I mentioned that we're working with other scientists on ASTM standard methods. We have members on the research advisory committee of the Pennsylvania Medical Cannabis Society, and we're doing outreach to folks like you at events like this. Recently, we had 2 articles published in Terpenes and Testing magazine, kind of sharing with the audience and the readers our experience, both from attending the Emerald Conference this year, and then just, basically kind of summarizing some of the things I've talked about in this presentation about this need for labs to have defendable data. So I think essentially it comes down to a few key things. If you're a consumer in this industry, you need to be asking questions about product labels, products and labels, and avoiding, the old school kind of snake oil salesman. Much of the industry is still cloak and dagger. People don't typically know who grew the plants or who measured them. Is there any documentation for those products? I think it's extremely important for people to understand the concept of natural variation. And in general, the product tested by the lab may not be what you're ingesting. So that number might just be a ballpark figure, but you might not be able to really glean much from it. The top right photo there shows the New York subway. And I think this kind of really shows the power of natural variation. We're all made of the same stuff, and yet we look different, we act different, we have personalities, and that's what makes the world great. Well, that's what the cannabis plant also has, that made of the same things, but it's because of these different combinations of those things that they have such diversity. I think it's also important as a consumer to know that when you go into a dispensary, the bud tender's knowledge may be anecdotal. It might be from their experience, but you ultimately need to determine what works best for you. You need to be doing self-titration through trial and error. Often you might not be able to consult with your medical doctor about these types of things because they might just simply not know. So you need to keep track of how you feel after ingesting specific products and perhaps start self-reporting what worked for you and what didn't in combating the symptoms of specific ailments. I invite you all to check out the website of miradati.com. This is one such entity that is developing an application for users to be able to self-report the effects of how these different products have helped them in alleviating their ailments. And I think it's important just to overall be an educated, savvy consumer. But really, it's about everybody in this industry questioning everything. Everything is brand new, and it becomes a challenge to kind of sift through what's scientifically proven and what's not. If you're a grower or a cultivator, ask to see your prospective lab's audit results or training certificates, even proficiency tests. Ensure, if you're a grower or a cultivator, ensure you're providing enough product to get accurate results. I know it's also a challenge because that product can also be sold. It's a valuable commodity, but at the end of the day, the patients that are buying the products are what matters most. If you're a lab, don't give in to pressures from clients wanting to pay for specific results, and ensure that there's proper training and to your staff and document everything. Make sure that your data is defendable. There's a lot of non-scientists in this industry. And again, it's worth repeating that just because something appears scientific doesn't mean it is. This could be data, instrumentation, scientific studies. Anyone can make any claim they want, but ultimately, where is the proof? Ask to see the data. If you are seeing data, ask what the error or standard deviation is. If it's not provided, move on. If you're looking at buying an instrument, ask how it's calibrated and validated. Are there standards that can be evaluated? Again, if there's no data to be shown, move on. And ultimately do your homework and make sure that you know what you're getting into. So when you look out at this industry, what do you see? I like this graphic because this lady sees the globe, and I look at cannabis as a global situation, not just one in Colorado or California. So what do you see? Well, I look at it like everyone needs to be ensuring that patients get the best quality medicine. And I don't mean just, people that are auditing labs, people that are running the analytical tests. I mean, everybody that's involved in this industry needs to be making sure that patients are getting the best quality. I think it's quite important for groups like our J. Lee Group to be providing expertise and helping to enrich the science. I mean, that's consistently what we're striving to do. We're also to help labs assemble the foundation for defendable analytics. There's going to be people coming after the labs. We saw it on a previous slide with the manipulation of data. If you have defendable analytics, you should have nothing to worry about. I think it's quite important that many entities now, including ASTM International, are generating standardized methods. This is going to be huge for this industry. And I think if our J. Lee Group had a mantra, it could be educate, train, repeat until that person that you're educating, training, and training finally knows. I think that's kind of the cycle that we're hoping to see. Lastly, we've all seen movies like this, propaganda and quotations like this, things like, this is not medicine, this is a cruel hoax that sounds like something more out of a Cheech and Chong show. Or Nancy Grace, people on pot are killing whole families, and good people don't smoke marijuana. And this is not to necessarily judge the negativity of these people that are viewing this industry. This is to show you that there's opinions like these out there. And when there's negative opinions out there from people that are in powerful positions, such as these folks, why would anyone want to attract even more negative attention to this industry by doing something unethically or not making sure that they're putting out quality products, and that the data that we're generating, the mountains of data that we're generating on these products are done with analytical acumen that patients can ultimately trust. With that, I thank you, and I'd be happy to answer any questions that you may have.
Thank you, Dr. Lupoi, for that informative presentation. We will now start the live Q&A portion of the webinar. If you have a question you'd like to ask, please do so now. Just click on the Ask a Question drop-down box located on the far left of your presentation window. Type your question into the box that appears on your screen and click the Send button. We'll answer as many of your questions as we have time for. So let's get started. Our first question is, do you think the industry will be coming out with standard methods soon?
That's a great question. I do think so. These types of standard methods are not something that can be done overnight. While we can look at several other industries such as nutraceuticals, pharmaceuticals, even agriculture, cannabis presents a very peculiar scenario in that it's also it's all of those. It's a medicine, it's a natural product, and it can also be a food product. And so I think that organizations that I'm affiliated with that are looking to develop standardized methods are perhaps rather slow moving to the eyes of others, but we're definitely trying to make sure we do our due diligence and get it right the first time, and make sure that there's a clear path that anybody affiliated with the industry can follow these methods, and ultimately, those standardized methods will be here to stay and won't require a lot of further fine tuning. So I would say that the short answer is yes. There will be standardized methods being shared with the cannabis community at large. But again, these types of things just can't happen overnight because they are very complex.
Well, thank you for that. Your next one is, do you think organizations will be coming out with standard methods soon?
Yeah, I mean, I think that ties into the last one where, these types of organizations like ASTM, AOAC, they're already working on these types of things. There's been some groups like the ACCL that have been trying to evaluate methodologies for the industry. And then you see like an organization like ASTM doing the same thing. So there's many different prongs to this approach. There's a lot of people coming out with different types of standardized documents. Some groups have even started to join forces and figure, why would everybody reinvent what others have already done? And so I think that all of those efforts will help us see this realization much faster.
Okay, we have time for one more question. Why don't labs put a potency range on products to better represent these sources of variation?
That's a great question. I've seen one lab and one dispensary actually utilize that system where you would see a range of potency. Now, I believe that lab may have been measuring things twice. Standard kind of rule of thumb in analytical chemistry is we measure things at least 3 times. I realize that's not very practical for labs that are trying to increase their throughput and help their clients get their products to market. But I do think that, while I don't know why labs haven't chosen to do this, I think part of it is likely because it's not required by states. If it was required by states, we'd see everybody doing this. And I think that, people involved in the industry that feel like that should be something that is a requirement, perhaps contacting the people involved in developing the regulations would be the best way to go about doing that. But I think that when we look at other products that are marketed, like food products, we don't see a range of things. We don't see a range of things like caloric content on food. We don't see a range of nutritional and vitamin information for your percent daily values on product labels. But again, like this is something that's called medicine, and I think that the error thresholds in the pharmaceutical industry are quite tight. So when you see something that says 100 milligrams, patients should be able to trust that. When we're putting something on a potency label that is quite limited, 25%, we don't know all the different, and you're not aware of all those different sources of variation. That can be a challenge to properly dose. So, I'd like to see at least some places start to do that out of their own accord and share with their clients, even if it's not going on the product label. People that are manufacturing these products would at least have an extra piece of data to kind of refine their processes at the very minimum.
Well, I would like to once again thank Dr. Lupoi for his presentation. I'd also like to thank LabRoots for making today's educational webcast possible. Before we go, I want to let everyone know that today's webcast will be available for on-demand viewing through June 29th, 2018. You'll receive an email from LabRoots letting you know when this webcast will be available for replay. Please share that announcement with your colleagues who may have missed today's live event. That is all for now. Thank you for joining us. We hope to see you again soon. Goodbye.